Have you ever noticed the angled rock layers in road cuts or swam in a river with perfectly rounded rocks and wondered about the stories hidden in those rocks? Most people pass by these natural wonders without a second thought, but those rocks have stories, rich, ancient, and full of secrets. Today we're diving into the fascinating world of geology, the science that lets us unlock these secrets. We'll discover how the very ground beneath our feet holds the key to understanding Earth's past, present, and future. So buckle up for an adventure a billion years in the making. Before we get started, make sure that you click the subscribe button, like, and comment geology if you're interested in learning more about this science. Alright, let's get into it. For over 2 centuries, geologists have been deciphering the stories written in stone. Imagine looking at a cliff and recognizing it as a rock formed on the beach of an ancient sea, or seeing the remnants of an alluvial fan. Geologists can do this because they've spent generations gathering knowledge and piecing together Earth's history like detectives solving a planetary mystery. But geology isn't just about the past, it's practical too. Thanks to this science, we've located reservoirs of oil, water, coal, and valuable minerals used in everyday items like our phones. Geologists have helped us understand how Earth's conditions have changed, sometimes in a blink of an eye, at least in geologic terms. By studying the shifting of coastlines, ancient volcanic eruptions, and even massive asteroid impacts, geologists help us prepare for the future and solve real-world problems. But before we learn about the rocks, we need to take a look at the giant space rock we live on, Earth. Earth is a truly special planet. Its distance from the sun, the size of the sun, and its ability to hold an atmosphere make it unique. These conditions allow life to flourish here, unlike on most other planets. But Earth isn't just shaped by biology, it's a system of interconnected parts. The land, the water, the atmosphere, and even life itself influence one another. For example, plants not only grow in specific climates, but they also shape those climates. Forests can trap heat, while other plants can alter atmospheric chemistry. This interplay between Earth's components is recorded in rocks. From volcanic eruptions to desert dunes, rocks tell the story of the joining of continents, the warming and cooling of our climates, and even the evolution of life. By studying these stories, geologists can understand how the planet's systems function and how they might change in the future. For example, as sea levels rise due to melting glaciers, the geologic record shows how coastal marshes have shifted over time. This information helps us predict what might happen to these vital ecosystems as human activity continues to warm the planet. Geology also reveals the fragility of life on Earth. Throughout history, the planet has experienced mass extinctions, some caused by volcanic eruptions, others by asteroid impacts, and some by more gradual climate changes. The geologic record shows us how species have adapted or failed to adapt to these changes. This knowledge is critical today as human activity accelerates extinctions and drives global warming. By understanding how life has responded to past crises, we can make smarter choices for our future. Now that we know a little bit more about Earth, let's dive into some fundamental geologic principles. The principle of actualism is an idea that is at the core of modern geology. It says that some of the natural processes that we see today, like rivers carving valleys or earthquakes causing fractures in the ground, are the ones that have shaped Earth for billions of years. For example, when geologists see ripples in ancient sandstone, we know these ripples formed the same way they do today, in shallow water under the influence of wind or waves. Although natural laws have remained constant throughout geologic time, not all events from Earth's past have been witnessed in human history. For example, the extinction of the dinosaurs 66 million years ago is widely attributed to the impact of a massive asteroid. While such an event has never been observed by humans, theoretical models based on physical and chemical principles help us understand its consequences, such as the widespread extinction. Geologists have also discovered rocks that no longer form under present-day conditions. These cases usually involve one of these 3 possibilities. 1. The rocks formed under past conditions that no longer exist. 2. The conditions still exist but occurred deep within the Earth's crust beyond direct observation. And 3. The rocks form extremely slow, requiring immense spans of geologic time. For instance, iron ore deposits older than 1.8 billion years ago reflect chemical conditions vastly different from today's environment and underwent slow alterations over time. These observations don't contradict the principle of actualism, as no natural laws were violated. To address such mysteries, geologists replicate ancient conditions in laboratories, subjecting chemical components to extreme temperatures and pressures. This allows them to recreate the textures and minerals found in natural rocks, offering valuable insights into Earth's history. Actualism replaced an older older idea called catastrophism. Before the 1800s, many scientists believed Earth's features were formed by sudden, supernatural catastrophes like massive floods. But a Scottish geologist named James Hutton changed everything. He proposed that everyday processes like erosion, volcanic activity, and sediment deposition shaped the planet over vast amounts of time. Hutton's ideas laid the foundation for modern geology. Later, Charles Lyell popularized Hutton's work in his book, Principles of Geology. Lyell argued that the processes operated at the same rates throughout history. While we now know that some events like asteroid impacts can cause rapid changes, Hutton and Lyell's work gave us the critical concept of geologic time. Without it, our understanding of Earth would be incomplete. Geology isn't just about studying the past. It's about understanding the present and preparing for the future. The more we learn about Earth's history, the better equipped we are to tackle challenges like climate change, habitat destruction, and resource depletion. So the next time you see a rocky outcrop or a mountain range, take a moment to wonder what stories are hidden inside those stones. Because every rock has a tale to tell, and geology is a science that helps us hear it. Thanks for joining me on this journey through Earth's history. If you enjoyed this video, don't forget to like, subscribe, and hit that notifications bell for more amazing stories about our planet. Until next time, keep exploring.